Hi, my name is Nicholas Imfeld. I'm a principal engineer at Avanceon. Here at Avanceon, we've been developing solutions for our customers for a long time. And in the process, we've run into and solved many interesting technical challenges. For this session, we're going to be focusing on system platform optimization, presenting some stuff around how to make it work best. So where did I get what we're going to be talking about? First and foremost, I found a system platform best practices guide for 2014 R2, and a lot of that stuff is still relevant, so it's a very, very good resource. Some other stuff, just information from elsewhere, from customers, from the WDN, and from just hands-on experience. Sometimes the best way to do this is to just do it. So we're going to start with system platform architecture. It's best to have separate machines for each function. You definitely should not run any of your software on it as a domain controller. Split it out. And yes, you can do virtualization. Continuing with architecture, it's recommended that for your GR node, you have a 4-core system with 4 to 8 gigabytes of RAM. That's for medium to large system. Obviously, every system is going to be different, but this is just a good benchmark. For AOS, an AOS is an engine that runs a process that can span only a single core. So a good target is a quad-core environment. Again, 4 cores, and we recommend 1 gigabyte per core. So again, you're looking at a 4-core, 4 gigabyte system. Terminal servers, again, you're going to focus on 1 core and 1 gigabyte of RAM per in-touch session. Increase as needed. And then for historian, we recommend 4 cores and 4 gigabytes of RAM. A lot of systems use redundancy. Anecdotally, I find that redundancy is responsible for more issues than it's solved. That said, you can do it. You should use the provided redundancy engines, but I don't recommend using the provided redundant SweetLink objects. Rather, use a standard SweetLink object with some scripting to perform the failover. So another comment on modeling. We recommend 2 top-level model areas. One's for the plant and the other's for just a system area for platforms and engines and all that other good stuff. So within your plant area, you want to add contained areas according to the logical organization of the plant. This organization is used for running runtime queries. The areas queried will include itself in any child areas. The model organization can also be used to locate historized data. These are not nested the same way that runtime alarms are. So give consideration to your nesting and try not to have too many layers because then it just gets confusing. So a platform is required for every machine that interfaces with system platform. Domain controller does not need a system platform. In-batch out of the box does not need a platform. However, if you're using IBMX for communication, which we recommend, then you do need a platform. And one-aware information system, which is kind of fading away, but it may not need a platform. Just depends on how you're going to use it. If you're going to use it to display orchestra graphics, yes. If you're going to just display reporting, no. So it just depends on your application. Engines and view engines. So multiple engines can run on the same platform. We recommend up to 4. Consider the performance specs we talked about earlier, 4 cores, 4 gigabytes of RAM. And we recommend that a single distinct engine and SweetLink object be used for each area. Essentially, everything's going to be self-contained. Each engine uses a separate thread, and each engine can be tuned to different scan rates as required by the equipment. We recommend that I/O count per engine not exceed 20,000, and so that's 4 engines. That yields 80,000, which you'll recall we talked about earlier. And you can determine your I/O count using Object Viewer. We recommend that the object count per engine not exceed 5,000. Decreases as more complex objects are used. So if you've got a lot going on an object, that's not going to be the same as a simple object. But again, just a benchmark to consider. You can determine your object count, again, using Object Viewer. So the view engines and object engines, they can run on the same platform. However, if running under under our recommended architecture, they never will, because you'll have engines on your AOS and you'll have your view engines on your terminal server. The system area should have its own engine and be deployed to the GR node. Engine tuning. The most important values are the engine scan period. So with a deployed engine, review in Object Viewer the scheduler.execution time average. You should update your scan period so that the value will yield an engine load of about 30%. It's also worth reviewing the overruns consecutive count, as this will tell you if your scan period's too fast for what you're running. A low number that's not increasing is acceptable. Typically, you'll have some overruns during deployment as everything's getting orderly, but once it's stable, it shouldn't increase at all. Just set the scan period on the engine tab of the platform equal to the fastest engine scan period that will be hosted on the platform. What about prime numbers? There's been a lot of talk over the years about using prime numbers to make sure that they don't execute at the same time. There's been a lot of talk about using prime numbers to make sure that engines never execute at the same time. This talk is quieting down. The software has been developed, and it's just very low likelihood that the engines will ever trigger at the same time because they're triggered sequentially on deployment. However, if you want to use a prime number, it doesn't hurt anything. And we've provided a handy table if you want to reference some prime numbers. Continuing on engine tuning. So on the engine tuning, we recommend changing the checkpoint period from 0 to 30 seconds. This is the frequency that a checkpoint file is created. And you don't need to do this every scan. So let's use those resources elsewhere. Also, read-write interrupts. So we have a customer whose standard practice is to enable standard interrupts and full interrupts. And so you can explore that yourself. But a standard interrupt is when all DI objects receive inputs from other objects and write to field devices during the object execution phase. Full interrupts, they send and receive, and all DI objects write and receive updates during the object execution phase. So OI servers, also known as DA servers, these are the communications from system platform to your field devices. At the controller level settings, we set to optimize for read, and we uncheck optimized user-defined types. Used to have this checked, but I actually encountered some problems where it made sense to uncheck it and haven't seen any issues. So since it solved my problem, I'm recommending it be unchecked. Device groups. You can have multiple topics and they can be configured for multiple update times. Usually it's for slow, medium, and fast. The idea is to have your communications spaced as required, not as fast as it possibly can be, just to optimize your resources. Again, you can use prime numbers here too if you want. At the beginning, we mentioned the System Platform Best Practices Guide from 2014. Yeah, it's worth downloading and reading because there's lots of good stuff in here. So there's specific notes on optimizing orchestra graphics, speeding up in-touch, redundancy, and some of the definitions of some of the settings that we didn't have time to talk about here. Additional reading. So we have some server scripting 1-point lessons, and here's just some high-level tech notes that are definitely worth your time, especially this first one, which is FAQs for IT professionals. There's just lots of good information about setting up system platform on an IT network. Some additional ones here, all of them are worth your reading. And as promised, prime numbers.